Okay, so none of this is going to make any sense to you whatsoever. That's not a great start. Um, but the structure will actually be, you know, I don't know if it's the same as the confidence intervals, but you can see what I have written up here. That I didn't want to write again. First hour I wrote it word for word. I guess that's nice for them because then they could keep along as I'm saying stuff. I'm writing it too slowly, but level of significance. Let's talk about the video I showed you 2 days ago. If you weren't here and you don't watch those videos, you lose so much. And it's getting to the point where I hope we start picking up these things as we go. A lot of the things that we're going to do here today are based off of stuff you should already know how to do. So that's why those that don't do their work, you have a snowball effect of failure, all right? And the things that we are supposed to know building up to this, you don't know that, then it's hard to really, keep going. And I'll kind of reference those things. But you again. This is 100% related to confidence intervals. And I wanted to have this blackened out so I could reveal these as we go. But I forgot and revealed these ahead of time. There it goes. It doesn't work. I have to have it exactly green. So I wanted to have that connection. I was going to ask you, what are the three most used confidence intervals 2 chapters ago? What was the number one? Because we could see this. Which one was used the most? That said was the most popular. 95. That's because you get some, I get people are most comfortable with that because it gives you some good results, I guess, the best. 99 was also another one, but what that is it's real picky, and it's really, but if something passes at a 99% confidence interval, then we have a lot of confidence to say something about that. And then 90 is another one. Well, look at this. When we talk about levels of significance, we're talking about the complements of these confidence intervals and where things fall. So notice that 90%, our alpha for a level of significance, by the way, going a little ahead of myself, this is another variable you're going to have to recognize. This adds to your variable understanding or recognition. We're going to have to understand that the variable alpha represents your level of significance. The three that we will use and only use are 10, 5, and 1, or 0.01. 1% is what I meant when I said 1. Those are 100% related to the complements of 90, 95, and 99% for confidence interval levels. And what we're going to do is compare that to a test statistic, which actually is going to be called P for probability. All right? And that calculation is going to be from using sample data and then trying to compare that to a population parameter. Ladies, having a great conversation back there? Mm-hmm. Okay, that's cool. She goes, not math. Oh, zinger to Mr. Samuelis. Oh, about math. Okay, my bad, dog. A little excited here on a Wednesday. Remember, I'm on 4 hours sleep, so I'm going to be a little edgy. A little bit on the edge today, all right? So let's just all relax. Okay, so now, one thing we got to remember, okay? What's a parameter? Which one's a parameter, this one or this one? I just wrote those underneath test statistic. Which one's a parameter, the one on the left or the right? The left. Which one's a parameter? This one or this one? Which one's a parameter? The one on the left. By the way, those last two variables I wrote, what are these variables for? Standard deviation. The one on the left is of the population. The one on the right is the standard deviation of the sample. This is our formula wrong. Variable recognition. By the way, what's that letter on the left called again? Mu. And it actually means mean. Average, like an average number. Hey, I got one more. What's this for? I know I got P, like I talked about P before, but what's P actually when we're doing certain questions in confidence intervals? P stands for proportion. What was the variable for the statistic? They're still having that great conversation. It's amazing. P. had, nobody answered that question. That's why I'm sitting here like an idiot up here. Got 29 students in here. Nobody. Okay, so we're going to have 3 different scenarios. Hey, you had 3 different scenarios when you did confidence intervals. This is why some of this is not going to be new. And those that are behind, well, it's new to you because you're behind. All right? The parameter. One situation was we had an average number, and we talked about the population's average number. And then we went to a sample, and we found that sample's average. And then we tried to say something about the population's average compared to that. But we had 3 different scenarios. One was, well, they're all normal distributions, or else we couldn't do what we're doing. And this, by the way, what was that again? I just put that up there. What is that symbol I just wrote there? Looking up and down. Standard deviation of population. Remember in confidence intervals, the first thing we did when that was what? Known. So this goes back to confidence intervals and what you had to do for that. And when we had that, what kind of test was it? Ding-a-ling-a-ling. Oh, no, that's my wife. Oh, boy. Get rid of that. Yeah, I don't want to see that email. Now you're going to pause the video and read that. Oh, gosh. That's great. My wife, hold on. I got to turn off my emails. My wife just sold me out. Continue. All right. What kind of test is it? Z, you got it. I didn't want to give you a hint. Those that know and remember this knew that we had to go. Oh, and then I lied to like 2 or 3 of my classes yesterday. You're going to need both sheets. All right, and you shouldn't have thrown those out anyway because you need them for the final anyway. But we're going to need the Z chart front and back, finding probabilities, and then the Z and T sheet as well. But not today. Not today. And I'll tell you how today's constructed. Okay, what was the second thing? Where we had this scenario, and it was, we'll say, approximately normal, meaning, and then I don't think anyone's, but if you do, this is going to be great. There was that one video I showed you where the guy had a sample, and it said, this is approximately normal, and as I add to the sample, ladies still having a good, boy, math is hilarious. And then as you add to the sample, the curve tends towards the normal curve. But I got interrupted during that. I just can't concentrate when I see people not focusing on what they're supposed to be. And then the second scenario is the standard deviation of the population is what? Unknown. Now you got it. You remember doing this. And then what kind of test was that? What kind of test was that when the sample standard deviation was unknown? And I showed you a video about YZ, YT to give you just an added percentage of understanding. And whether it was there or not, you didn't need it. You just needed to know to do that. But I tried to go deeper into there. And then what was the last kind of scenario we did? I'm just going to leave this blank. What did we have when it wasn't mu? What was the last thing that we had? I wrote it up here, actually. P, and then what's the sample statistic? P hat. And what was this automatically for some reason? What kind of test was that? Z. Okay, so this chapter you're going to get new formulas. I'm thinking about doing what I did last chapter that I didn't do for last year's students, so you got ahead a little bit more than them. Giving you the formula sheet ahead of time, and then you can mark your formulas as you go. And then I give you a formula sheet on the test, and then you have a better chance of knowing what's what. So I really want you to do well. I'm giving you every possibility to do well. You just got to, I'm giving you the water. You got to be the horse that decides to drink it. You just called me a horse? All right. So now, what's this p-value? Okay, not probability. I'm sorry, it is probability. Whoops. Not proportion p. Proportion is a specific type of scenario that we can do confidence intervals and then also say some things. And I'm going to try to equate this to the video yesterday, the guy guessing cards. Mathematically, can we have a sufficient evidence through mathematics at a certain level of confidence that this person is special at guessing cards, Or is there not evidence to say he's special at guessing cards? Those looking around that were absent yesterday and didn't watch that video have no idea what I'm talking about. And that's your problem. Okay, so p-value is a probability value. And, of course, it represents area under the curve. And it's the probability of obtaining a sample result with a value as extreme or more extreme than the population parameter. This sentence probably has 0% understanding. And not that I'm going to say we're going to go back to this and relook at this sentence, but as we do the next 6 distinct, unique sections, probably drawn out over 12 days or so, because we'll get some reviews in there and some, trying to get it all put together. This is what we're actually doing. And then it really depends upon the type of test. So this sentence really is going to have a whole lot of worth probably right now. And I'm really just going to hold off because it's not until the end that we're done with this that we could reanalyze the sentence. Not that I'm saying we're going to do that. And I lost my mouse, so I got to do this way. Pause. Really should be something that we should do well with at the end here. It may take a while for some of us, but it's those that are behind on our other things that we've done before that might have a problem here. But we'll actually hit everything as if it's brand new. So some of the things that we did last chapter might start sinking in. Okay. Now, this is just because so everything is standardized in a way so that everyone does the same thing. This is the most important schematic for the next 6 unique things we're going to do. That's why this is the most important thing. Everything that I've done up to this point is irrelevant. You could still get an A triple plus if you hammer the next couple things down and then we get the next example right without a high level of understanding. That is 100% true. But these are the rules. And this is because it's standardized, so everyone does the same thing. When we do these tests, in the beginning, to do what we're going to do, this is always based off of what we say about H sub A. What does H sub A stand for from your homework yesterday? What's the wording? H sub A is the alternative hypothesis. What does the alternative hypothesis always have in it? Not a what? No what? Equal sign. So it's either less than, greater than, or what's the last one? So now what we have to do is read our sentence and analyze what is H sub A. Now for the first type of test, we're going to show you how to mathematically find this. So this is just a setup. Is a left-tailed test. And I don't understand how people screwed this up last year because it's common sense. You have a left-tailed test when H sub A, what do you think is? Less than or greater than? What would be left on the number line when you're less than or greater than? Left on a number line? You'd be less than. So when H sub A is less than a value, then, or if mu is less than, or p is less than is what I really should say. So if H sub A has less than in it, then this is a left-tail test, and this is what it looks like. And actually, I'm going to add something that I didn't add last year. It's probably because I didn't have a firm understanding of it, and that's really the truth. That's where our shading is left of a p-value that you are going to analyze. Now, I want you to add this because this is a mind blower. And if you actually get this down, then you're going to be like 100% solid for this. Now, what is the purpose of this area? This actually says something about H sub O. So we use H sub A to do this drawing, but then from this drawing, we say something about H sub O. If our p-value that we're going to find falls in this area, then this is, analyze this sentence. This is a fail to reject, and you don't know anything about this yet, so just hold off, H sub O. Maybe even after we're done with this, you won't get it. But let's analyze that sentence. And I said this in all 3 classes so far. What's fail? Is that a positive or a negative? What's reject? Is that a positive or a negative? So isn't this a double negative sentence? What does that mean about H sub O we're actually then? What are we doing? We're liking it, right? When we fail to reject, we like, or we have evidence to support is the way this is going to be worded. Last year, people had problems with the English and didn't understand what fail to reject. This is just the terminology of statisticians. Yes, maybe it is a little bit too convoluted and complicated. We can handle it. We know English. So if a p-value falls in this other area, what's the opposite of this? Or we reject H sub O. Therefore, there isn't evidence for H sub O. So I know this can be done different. People, what does that mean? Let's go back to fail to reject H sub O. What does that mean about H sub A then? We reject H sub A. What if we reject H sub O? What does that mean about H sub A? We fail to reject it, and that's what's going on here. So it's either one or the other, and then this is how it all works out, and we'll hash this out later. Don't give me the I don't get it yet. We can't actually answer those questions at a high level because we're at the very beginning stages of this. Okay, so let's just kind of try to let it sink in as we go. All right, so right tail test. By the way, on a number line, what's right? Numbers that are less than or greater than? Greater than. So in a right tail test, you got to remember this is in terms of what H sub A, I should write this better. This is when H sub A has greater than in it. So either mu is greater than or p is greater than a number. And that's the only two things that we're going to have. It's either mu or p. Okay, so I wrote that as H sub A is greater than or less, and it's not really true. Mu or p is what we write. Okay, so when that happens, this is what the graph looks like. Sorry for my bad normal curve. P-value over here and shaded over here. And then for purposes of understanding, the open area is still the fail to reject, but it's always in terms of H sub O when we make this conjecture. And again, this is just what somebody decided. But if we fail to reject H sub O, that means we reject H sub A, because it's one or the other. It's not an acceptance. We're going to say there's evidence to support it. And then this is the reject H sub O area. So that means that we fail to reject H sub A. Fail to reject means support, or there's evidence for it. Okay, and then what's left for H sub A? What could you have H sub A as from your homework? There could be a not equal to. That will end up being a two-tailed test.
Is that p hat when you put the star next
No. Wait, where?
to
No, that's a mu. Right there. My bad, dogs. Riff. Two-tailed test looks like this. Okay, then what's this area? Reject or fail to reject? Fail to reject who? Ho. All right, and then this is what? What did he say? And then this is the reject H sub O region, which means fail to reject H sub A. Oh, I'm sorry. This is when H sub A, oh, I shouldn't have put that in green. This is when H sub A has a not equal to in it. That's the third thing that you had in your, when you were writing those things in your homework yesterday. So notice how the homework builds on one another. You don't do yesterday's homework or Monday's, and you didn't make these, what's H sub O or what's H sub A, which one's the claim, what's the inequality. Well, that's where you're causing yourself all these issues. And that's the truth, and it's tough to fight that. Okay, here we go. All right, so now, here we go. Is everyone all right? If, okay, now here's where we make our conjectures. We're going to have formulas, okay, to find the p-value, and then we have to compare it to alpha. What was alpha? Alpha was your level of significance. One of those three most common is what we're going to use. Either at 10%, 5%, or 1%. 5% being the most popular because 95% confidence intervals are the most popular. If we find this p-value and we find it to be less than our level of significance that we decided to choose to make our conjecture, Well, look at this. When P is less than, let's look at the left-tailed test. Then you're in this region here. You're in this region for that p-value, which is the what region? What's in green right above that? Reject. So what you're going to do is, through some formulas, which we don't have today, but I'll talk about that a little bit today, you're going to find a p-value and compare it to your level of confidence. And if p is less than that level of confidence, then we reject H sub O. And we already said this. When we reject H sub O, what does that mean about H sub A then? We fail to reject H sub A, which means there's evidence to support H sub A. And that's how it's going to be worded. We don't accept it. That's too strong. We say, hey, there's evidence at a certain confidence level to say, let's talk about the card guy, to say the card guy is special in guessing suits. I have mathematical evidence to say that he is special. Or I have mathematical evidence not to support that he's special. That's how you'd word it. So that's what we're trying to get at here using the card guy. Remember when hey, let's say he guessed 44 out of 100. Then we'd have mathematical evidence because of the small probability that he actually does have something special going on there. So if, what's the opposite of this? Greater than or equal to. We'll fail to reject. Now this is what's weird. Remember yesterday, your claim could either be H sub O or H sub A. So you got to be careful. That's why I'm writing in green the opposite of this. That means you would reject H sub A because it's one or the other, which means evidence supports one and doesn't support the other idea. But now what you have to do is make sure what's your claim, and then write your sentence in terms of the claim. So here's a redundant. This is just a reiteration of what I wrote in green compared to the red. Okay? One of these two will be the claim. So, if I write H sub O and H sub A and reread the sentence and this is the claim, and I end up having a rejection of H sub O because of my first thing that I wrote there, all right, then what I would have to say as a sentence is, there is not sufficient evidence to indicate, let's go to the card guy, that the card guy has a special ability. But let's say that the claim actually was H sub A, and that's what they were trying to claim, and this happens. Then the sentence would have to be, there is sufficient evidence to claim or indicate whatever we're trying to claim. So again, you have to, very first thing when you read a sentence is, what's H sub O, what's H sub A, which one's the claim, because then at the end, you have to write a sentence in terms of what we're trying to claim. Okay? And then I'll reiterate that with this as you write this down, you good note takers, which are good. Or, you could have the second inequality that's right above here. This happens, which means we fail to reject H sub O. But what if this is the claim? Well, then if that's the claim, then H sub A does not have evidence. Because we failed to reject H sub O, that means we reject H sub A, which means there's not evidence for H sub A. Or, can't erase. That's good that I'm stalling because some people are writing notes. Say we have this inequality happen which fails to reject H sub O, and H sub O is the claim. Well, then that means there is sufficient evidence for the claim because of what happened with P and alpha. All right? So hopefully that's clarified. I think I did a better job than last year in getting that distinction. And this is the distinction for the next 6 unique sections. It really is. Plus. True that. Okay, so I don't know why I started the video. Read this. I'm going to let my class write this down, so I'm going to pause it and get right into it. I'm going to start the video. So I just read that to them, and you should have read it at home if you're not here. First of all, is this a good random sample of all college students? What do you think skewed about this sample? It's Harvard. Like Harvard, when it's really hard to get into Harvard, And then when people graduate, I think we all know that people that graduate from Harvard get more high-paying jobs. Isn't that right? So someone could say right away that this sample is skewed if we're going to try to say something about all colleges. But we're going to proceed. But I think there is a major bias in this this situation. Here's my next thing. You don't have to do this today, but remember what I said earlier in the notes. We're going to have situations later that standard deviation of the population is known, not known, and proportions. By the way, is this a proportion question, yes or no? Is this a proportion question, everybody? No, because I don't see a what. It starts with a P. E. Percent, or it doesn't say, it doesn't say 500 out of 1,000 students do this, right? Right? So this is not a proportion. So my next question is this standard deviation of the population known or not known? Harvard University sampled 500 students and found from that sample the average salary is this, and from that sample the standard deviation is this. So is this a population standard deviation or a sample standard deviation? So is this a Z-test or a T-test? When you get into having to use a formula, this is a T-test. And we need to understand that, and that's what things that weren't done when we did confidence intervals weren't done well enough. Okay? All right, so let's just remember. But we don't have to do that today. But again, these are things that we have to know as we proceed further and make these distinctions. Okay, from yesterday. What is the claim? Is it H sub O or H sub A? Read the first sentence again. Is it H sub O or H sub A because of how this works so everyone does the same thing so it's standardized? It is H sub A. I heard someone say, why? What word? There's only one word that tells me. I couldn't hear you. Someone's coughing. Not is larger. What does larger mean? What symbol is larger? Greater than. And then what is this? This is mu because it's an average. So the claim is that the average salary is greater than 48,000, which belongs in H sub A because H sub A never has an inequality. And that is the claim. So at the end when we write a sentence, it's going to be in terms of this claim. No matter what happens with reject or fail to reject H sub O, we have to find out what that means about H sub A and then write a sentence about it. By the way, what's the complement of that then? What does that make H sub O? Now, let's be honest. I care about your last sentence now. We're not writing these sentences anymore. Okay, I know what these mean. It's a redundancy. And too much writing. I'm going to be nice. I'm not going to be a stickler about writing those sentences anymore. I just wanted you to get day one, step one, hammered out. And then from there, we use step one to move on to step two. Okay, now, I will be honest. Look at what it says after this. What can you include at a 5% significance level if P equals, where did this come from? Well, what you're going to have to do is use a formula. You're going to have to get P from a formula with the given parts in this. By the way, what's N? What does N represent? How many people were asked? How many people in the sample were? 500. What else? What's X bar? So these are things you're going to have to do. So let's do it now, and I'll tell you about it. What's X bar? So from the sample, we got this average. And then from that, we're going to try to say something about 48,000. All right, and then one more thing. What is 1,500? What is its letter? Because this is what ticked me off. People not figuring out that this is sample standard deviation. So then when they go to their formula sheet, what letter is in the formula? What letter is sample standard deviation? Uh-oh. It's not this. It's S. And your calculator, we used our calculator to find that. That's why the formula sheet has S in it, not lowercase sigma. So the formula with S in it is the formula that I use. So that's why this should not be hard. All right, so what I'm saying is there's going to be a formula for a t-test. You're going to plug that formula in, find out something, and then, actually, this is kind of a lie. It could be a p, but something a little different happens with the t-test. That's where this number comes from, okay? And what we're doing today is we're not worrying about the formulas right now. We want to get the structure down, the structure of how these questions work. By the way, what's alpha? What is alpha? Ooh, what is alpha? Alpha is your level of significance. So what is it? 0.05. What is the comparison between P and 0.05? Is it less than or greater than? This is why I said you can survive without even understanding this if you just memorize. What is it, less than or greater than? Well, I hope to gosh you know that it's less than. I can't help you on that one. 0.01 is less than 0.05. And then what does that mean? What does that mean when P is less than alpha? Not that you understand it. You could just do it though. What does it mean? Reject H sub O. So now we're going to write that. Since P is less than alpha, we reject H sub O. I wouldn't mark you wrong if you said we fail to reject H sub A, because isn't that true from what I said? But we'll write this. Then we'll say in terms of the claim what happens. Therefore, I don't know, there is, I just want to make sure I don't, there is, I wish I could write faster, sufficient evidence to support, isn't this stunning? The claim that graduates, how is it worded? I can look at this sentence. That 3 years after graduation from college, 3 years after graduating from college, let's just say graduating from, and I don't care that you do that, that's fine. The average salary is greater than 48,000. Okay, and that's what we're trying to say there. Okay, so you put it in terms of the claim. The claim was this, so your sentence at the end must be in terms of what the claim is, no matter what rejects or fails to rejects. Okay? Now, again, at the very beginning of this, what can a person say about the sample? The sample's skewed because we only looked at Harvard, and we're going to say Harvard graduates compared to the rest of the world's or the nation's graduates, a little bit different. So the sample is a little not representative of the whole population. That's besides the point. That goes back to the very beginning of this this statistics since January. All right, good.